So, my name is Brian Farrell, and today I'm going to talk to you guys about deep learning. Specifically, I'll talk to you about what it is, what it's used in, and a little bit of how it is under the hood. So, first of all, what is deep learning? Well, it's a method of machine learning, and what machine learning is it allows a computer machine to learn given its context and eventually figure out a solution to the problem without being programmed explicitly by a computer scientist or engineer. But most of all, it's really good at recognizing patterns. So some cool applications that deep learning is used in is DeepMind by Google. They made this, and this network was given access to many Atari games. And I'll be talking about Breakout right now. So what DeepMind did is it was given input of just the pixels on the screen and a rule to maximize the amount of score. So it was after an hour, it was able to hit the ball at 30 to 40% rate. It didn't fall past it on those other ones. So after another hour, it didn't miss the ball at all, which is much better than I can do. Terrible game. After another two or three more hours, it was able to play offensively and strategically. And if you see right here, it found out that if you tunnel through the left or the right, you can start bouncing off the top and hitting those bricks. And it seems much better than I've played. Never even thought of that. So some other applications are like speech recognition. So you can tell what someone's saying, but you can also get the context as well. Are they happy? Are they sad? Are they lying? So stuff like that. And also some applications like projection models for like maybe economics or business. Or even it goes to search recommendations. You might want to watch this on Netflix. You might want to buy this, Amazon. Text analysis, just like speech, you can tell what people are saying, the context, if they're lying. Image recognition, though, is very interesting. So how it's being used right now is the self-driving cars. So these video cameras, they're getting constant feed, and it's analyzing the images and seeing, oh, this is a person, this is a pedestrian, watch out for that. This is a stop sign, we need to stop. So it's able to get all this input and sift through it and get the right data it needs. And also video, it's able to get real time, is this person a threat or not? I thought that was very interesting. I didn't know that until recently. So now that we know that, what's used for, how does it work? So got to bring it back down to a neuron. So with a neuron, you have three parts. You have the body, you have the arms or dendrites, and you have a tail or the axon. So the arms get input from other neurons, process it through the body, and then output a signal through the tail. And if you get multiple neurons together, you get something called a neural network. So you can see this neuron or node, I'll be using node from now on for simplicity, but this node is connecting through these other nodes through its arms, and then these tails are sending the signals up. So now that we do that, we can add strengths to these signals, and you can assign a value between 0 or 1. And then we can add information to each of these nodes, such as letters to build a word. So we'll just use 0 and 1 here to make it easy. You have C, A, D, and T. C, A, T, the signals are on, but D is not, so it builds the word cat. It sends that out. So after that, we can build even larger decisions, such as you have all of these letters, and you have multiple connections to each of these other nodes, to this other layer. This is one layer, and this is another. This is the input layer, and that is the output layer, the collections of nodes on each level. But you see that the signal from C, it's sending the signal to cat, but it's not to dog. And you go through all the way here, and then you can build words from each of them. But that's how the structure is, but how does it actually learn, right? So we'll give it a test. So first we go through, we get all the attributes that we're going to give to it, and we have the decisions, is it a cat or is it a dog? So we assign random values for these strengths, and then we run it, and then we say at the end, this is a dog. So we average together the strengths, we find the average, and then we find the complement of that. 1 minus that, and that gives us the error rate. We want to minimize that to 0. So we're going to go ahead and change that. So what we do is we get all of the connections associated to dog, and then we increase those a little, and we decrease the others. And now that we do that, we can recalculate the error rate, and it's 0.5. If we keep doing that over and over and over again, then the error rate will decrease significantly, and we can give it this information, and it will say it is a dog. So it learned, very simply, but it learned. And that process is called backpropagation. So now that we have that, we can build even more complex decision networks. So we have the input layer, output layer, and these right here are called hidden layers. And this is what makes deep learning deep. The fact that we have these hidden layers, and it's very, very large vertically. But what this is good for, let's say, for example, you want to buy a house. You have the attributes of square footage, the year it's built, how many bedrooms, how many bathrooms, stuff like that. So you want to find out what it's worth, the price of this house. So you could say it has a lot of bathrooms, it has a lot of bedrooms, it has a lot of square footage, and it is by the ocean. You'd say that's a lot. So, but at the same time, if you get a really old house, it could be historical. So that could make it be worth even more. So that would be another decision right here, or even another layer, and then you add all these together, and then you get one large network of decisions. And another example, a good example of a network here is trying to figure out making sentences together. So you have all of these inputs, just letters, and then together they build strings of characters. And then after that, you put those together, you get words, and then multiple words, and then sentences, complex sentences, paragraphs, essays, and it will go on. So today I talked about what deep learning is, how it's used, and finally, how it works a little. So if any of this interests you, then look up these terms, and you'll be able to find out more on the subject.